This is question 2, part 3. Um, the this is just a continuation of that last question. Okay, we had this ball and the spike. Okay, the mass of the ball was 3.5 kilograms, and it strikes the spike, which is zero point 0.8 kilograms, and moves along with it. So this is an inelastic collision. Energy is lost in this collision. And we have to show that the energy dissipated as a result of the collision is about 10 joules. All right. So first of all, I underlined my unknown or my givens here: 3.5 kilograms, 0.8 kilograms, and I had 5.6 meters per second, which was my velocity when the ball struck the spike. Okay. And here's my unknown. The energy dissipated as a result of the collision. I have to show that it's 10 joules. Okay. So first thing I want to do here is I want to figure out how much kinetic energy does the ball have as it strikes the spike. All right, and I did this ahead of time just to save some time. Kinetic energy initial, KEI, is equal to 1/2 mv I squared. There should be a little I here. Okay. Therefore, kinetic energy initial is equal to 1/2 3.5 kilograms times 5.6 meters per second. And I square that, I end up with 54.88 joules. Right? I'll figure out I'll fix the significant figures later, but right now I'll just keep it as it is. Okay. The kinetic energy final is equal to 1/2 times my mass. Well, what's my mass? I need to figure that out. My initial mass, or sorry, my final mass is equal to 3.5 kilograms plus 0.8 kilograms. Okay. This is my final mass. Okay. This equals 4.3 kilograms. Okay. So my final mass is 4.3 kilograms. Okay. Times v squared. Okay, so what's my final velocity? What's the velocity after the two objects come together, the spike and the ball? Okay, what I'm going to do first here is I want to calculate the momentum, the initial momentum, and I know that in this collision, momentum can be conserved, just not energy. So the initial momentum and the final momentum are equal. Pi equals Pf. All right, I just want to show that there. Okay. So what's my initial momentum? Pi equals 3.5 kilograms times 5.6 meters per second. -1. Okay, so my initial momentum is equal to 19.6 kilogram meters per second. Okay. Now, what is my now what I can do is I know that my initial momentum and my final momentum are equal. Okay. In inelastic collisions, remember, momentum is conserved, but not energy. All right. So my P final is equal to 9.6 kilogram meters per second as well, but the mass is greater, so the velocity drops down. Okay. So I have 19.65 or 19.56, sorry. 18.56 kgms to the -1. -1 divided by 4.3 kilograms. Okay, and I end up with 4.54 meters per second. .54 meters per second. Okay. Now I can plug this 4.54 into my kinetic energy final. Okay, 4.54 squared. Meters per second squared. And KEF equals 44.31. Okay. KE initial minus KE final equals energy dissipated. There we go. Okay. Sorry, that looks like a 5-year-old wrote it, but I'm not 5. All right, it's just the pen. So you can see right here, I'm not going to show the next step. I don't really have that much room. If I take 54.88 and I subtract 44.31, I get about 10. All right. So yeah, that's this problem solved. I will see you in the next video.